So hi everyone, welcome to the second video of the 100x Devs YouTube Bootcamp. In this bootcamp, we're trying to cover a bunch of technologies that lead to high-paying jobs in 2024 that are not already out on YouTube. Video 1 was basic Docker. We understood what is Docker, what is containerization, and how you can create small Docker machines / containers on your own machine. In this video, we're going to cover some advanced topics in Docker. I would urge you to go through video 1 first and then start here. I will be recapping things a little bit, but it might be a good idea to first go through the first video. It's like 1.5 hours, something like that, so it's not too long. Go there, check that video out, and then come to this video where we'll cover a bunch of advanced Docker topics, things that I feel are enough to be able to understand open source code bases, more specifically understand the Docker file of open source code bases and set them up locally. In fact, in the end of this specific video, we'll open an open source code base, we'll go to the Docker file there, make sure we understand everything and are able to set up that project locally. With that, let's get right into it. The second video of the 100x Devs Bootcamp. This is Guide to Docker for Open Source, Part 2. Let's quickly recap what we did yesterday. Yesterday we did 1, what is containerization? What are the benefits of this fancy technology that was introduced a few years ago? What is Docker? How Docker leveraged containerization and became like the benchmark for creating containers. How Docker makes money when it was introduced. What are the commands, CLI, engine, things that it provides you so that you can use it and containerize your applications. Number 3, how to install Docker in your local machine, how you can play with it. Number 4, what are containers? What are images? Very popular interview question. The difference between a container and an image. Number 5, creating a basic full stack application. We created a MERN stack application, basically just the back end of it, not the front end. The back end, however, was serving some HTML, so it's sort of a full stack application. We also created the Docker file for it to be able to containerize this full stack application. Number 6, we containerized the backend. We deployed this image to Docker Hub. We understood what is Docker Hub, how does Docker make money, and how you can deploy your images there. We pulled the Docker image onto an EC2 AWS machine of mine and we started that Docker image there. I urged you to run the same command on your own machine and you would be able to see the code running on your local machine. Number 9, I told you a bunch of flaws in our approach yesterday. I gave you an assignment that said there is a small flaw here, try to fix it. That is something we'll discuss today. That's how we'll start the video today, with the solution for that assignment. And lastly, we discussed a little bit of caching and layers in Docker. Today we'll discuss that in more depth. So this was yesterday, and what is today? Number 1, we'll understand caching in images, layers in Docker. Once we understand that, we'll try to basically solve the assignment from yesterday. It should be very easy to solve the assignment once you understand caching well. Then we'll understand 2 advanced concepts that you need to know. One is volumes, one is networks. Why do you need it? And we'll also be adding a database to our backend application. Right now, our backend application is pretty skeletal. It doesn't have too much. It just basically does nothing. It serves an HTML file. We'll add some basic database logic there because we need to run with multiple containers now, not just a single backend container. We need to understand a few of these concepts. We need to introduce another container that has a database. Specifically, the database that we'll be using would be MongoDB. Very basic stuff. If you don't know Mongo yet, if you don't know MySQL or what a database is, I think you'll be fine. Number 3, we'll understand something called multi-stage builds. This is important if you want to open source code bases. In fact, the one that we'll open today does use multi-stage builds. Understanding Docker Compose, creating a Docker Compose for our own backend application, and then finally going through the open source project. These are the 6 things that we will cover today. Again, if you haven't gone through video 1, please go to video 1, complete it, and then come to this video. We'll take things from the very basics very slowly, hopefully by the end of it. All these 6 things are clear, and I feel these 6 things are enough, frankly, more than enough to be able to at least set up projects locally, create your own Docker files, Docker Compose files, and containerize your own full stack applications. Once you know all of this, I would urge you to find open source projects and containerize them. There are a bunch of open source projects that don't yet have Docker files. Go out there, find such an open source project, create a Docker file for it, create a Docker Compose file for it, the other thing that we're learning today, because this is a super impressive first contribution to make, because it makes the lives of other open source contributors into that project much easier. This is what we'll cover today. Let's get right into it. Let's begin with understanding caching and layers. We discussed this a little bit yesterday. What I told you was whenever you have a Docker file and you run docker build, what happens is Docker starts to create these layers one by one. It starts from the top of your Docker file. One by one on every step, it creates a new layer. For example, right now we have 4 steps here that would lead to a new layer creation. The first one, the one that grabs the node image from the internet, creates layer 1. This would be like a pretty fat image, let's say 900 MB or so. And this would also take a lot of time to come from the internet onto your local machine to be able to build the rest of the image here. So this will probably take like 2 minutes or so to come from the internet to your local machine. And this would be a pretty hefty layer to begin with. After that, we simply said, "Ke bhai workdir, let's set the working directory to a certain directory," which was in our case /user/source/app, which means this will be like less than 1 second maybe, and would probably put 0 space onto your image. We're just changing the directory where we want to put our final code. Copy ... This is the command that will probably increase some space and also take some time. So maybe let's say 3 to 4 seconds, and we'll add whatever 100 kilobytes to your image, because you're copying over the complete code base onto your current image, which is basically a combination of layer 1 and layer 2 right now. Once you're done with layer 3, you reach layer 4 where you run npm install. Now this is a long step because this actually brings external dependencies into your image. So this would probably also be like 30 seconds and will probably add whatever, let's say 90 MB to your image. These are the 4 steps that Docker takes for this specific Docker file to build. Layer 1, layer 2, layer 3, layer 4. Why does Docker introduce layers? Why can't it just create a single image and then add things there one by one? What's the benefit of adding layers? And the answer is the thing that I discussed in the last video, which is it helps a lot in caching. If you ever change your Docker file where you say, bro, I want the working directory to be something else, then at least the layer 1 can be reused. Docker can be like, okay, I do already have this layer 1, which I brought from the internet, which is the node 20 image. I know this second step changed, but the first step did not change in like a subsequent build. So I will reuse this specific layer, and then the layers from there change. That is the one of many benefits of creating layers. That's the reason Docker creates these layers, because these are very hefty files. If every time you ran Docker build on your machine, it had to re-bring the node image from the internet onto your machine, it's not a great idea. If it's cached, it's a beautiful idea. This is the reason why Docker does layering, and if you want to see layering in a much more visual fashion, this is what layers look like. Layer 1 is like the central layer, which as I said is 1 GB. This layer is the Node.js image, and then on top of that you have layer 2, layer 3, layer 4. What does on top of it means? It basically means that first 1 GB file system is created, which has node, NVM, all the jazz, like file system, node, a bunch of other things, network information. Once you have all of that, you change the working directory. So now you, on top of this file system, added a few more things here. Your image size increased a little bit, and then on top of that, you added some more things, and then you keep going like that. This is why this is what Docker does when it sort of creates layer one on top of the other. The problem is, if layer 2 changes, that means every layer from top of it also changes. So if you ever change layer 2, layer 3 and layer 4 will also change. Layer 1 would of course be unaffected. It's the same thing I discussed in the last slide, which was if you ever change this specific working directory, this can at least be reused. This cannot be reused, this cannot be reused, this cannot be reused. Similarly, if you ever change just the index.js file, then this can be reused, this can be reused. This step now has a new index.js file, something has changed, which is why this cannot be reused and this cannot be reused. Why is this good? Because, okay, at least 900 MB of work is already done, at least 2 minutes of work is already done, and your Docker build takes much less time now, thanks to it being able to reuse an image from before. All right, let's visualize this one more time. Layer 1, over which layer 2, over which layer 3, over which layer 4. If you ever change layer 2, which means you change the working directory, layer 3 and layer 4 will change, but layer 1 will still remain there, which was the most heaviest step, the step that added 900 MB to the image, the step that took 2 minutes for the node image to come to your local machine. Why layers? As I said, there are three important reasons why you need layers. Caching, reusing layers between builds, which leads to faster build times. This is like a popular interview question. Let's visualize this again. This is what our Docker file, more specifically the layers, look like. The first four commands are what lead to layer creation. So let's just look at these first four commands. From Node.js gets the node image from the internet, that's your base layer. Working directory changes the working directory. Copy copies over your code base into the image. npm install runs npm install, which means brings a lot of external dependencies from the npm registry inside your image. What if we change the code base to look something like this? Sorry, not the code base, the Docker file. There's a very subtle change that I made. The first one is still the same. The second one is still the same. I added a third step here. We now have 5 layers. Notice the change that I've made in this specific Docker file. What difference do you see? I'm not copying over everything first and then calling npm install. What I say is, I will first copy over package.json. That's what package star space dot means. Package star means any file that starts with package, bring that and copy that over to our image. Then I say run npm install, and then I copy the rest of the files into my image. Why did I do this? The answer is the assignment from last week. The assignment was, the problem statement from last week was, okay, yaar, what happens if you run docker build twice? You run docker build the first time, you have the layer 1 that's created, layer 2 is created, 3 is created, 4 is created. Let's go back to the slide before. You have these 4 layers that are created. This takes 2 minutes. This takes whatever, 1 second, let's say 10 seconds, and let's say 2 minutes. This is the amount of time that it takes for the image to build. But if I run the same command the second time, Docker understands that bhai, this is cached, this is cached, this is cached, and this is cached. I can reuse all of them, and it takes like, everything takes 1 second or so, because everything is cached. This is the benefit of caching. But if I change the index.js file between builds, which means if I run docker build once, then I change, if this is my code base, I change the index.js file, and then I run docker build again, what would happen? This step changed, which means layer 3 changes, which means layer 4 changes, which means we're running this very expensive step again. But we shouldn't run this very expensive step again. Why? Because package.json did not change. And package.json is what infers what this thing does. If package.json ever changes, more specifically the scripts, not the scripts, the dependencies inside it changes. Let's go to the code base here. Let's look at the code base from yesterday. If I look at the package.json file, it has a dependencies section which says express right here. If I run npm install, not here but inside the Docker image, what would happen is a bunch of external dependencies would come here. If I change my index.js file to whatever, let's say I remove a few spaces here and make a bunch of other changes. If I rerun npm install, it still brings the same files. I did not change package.json, and this lines or a bunch of lines here, if I add more dependencies here, for example, let's say I add course latest. This is another dependency that I can add. I can keep adding dependencies here. If this file changes, then sure, npm install's output would change. But when you're in an open source project, when you're in a project of your own, package.json does not change very often. Only your actual code base changes, which in our case is this index.html file. With this information, with the fact you knowing that index.js is what changes more often, package.json does not change very often. If I change my Docker file to look something like this, do you think my problem is solved? The final copy is happening at the very end. The index.js is being copied over into the image at the very end. Before that, 4 steps are running. Step 1 and step 2 are straightforward. Step 3, the new step that we have added is, it says, bro, copy over package.json into the image. Don't copy over index.js. So this layer, by the end of this layer, what do you have? You have a node image. Inside the node image, you have a package.json, and that's it. You don't have the index.js file here. At layer 4 is when you run npm install, is when you have node modules here, which means you bring express and a bunch of dependencies into the image. At the final step is when you copy over index.js into this image, which means if index.js changes between builds, only layer 5 is rebuilt, and the expensive layers, more specifically the npm install layer here, does not rerun, does not need to rebuild. It can be what's called cached. That's the benefit. If you want to see it more visually, we have 5 layers now. Let's say these are what our layers look like, and I change the index.js file. Only this step changes, which means only the last layer will change. Everything else can be recached. If you want to see this more practically, I have a solution file here. So let's go to 2.solution/1. Again, this is all on GitHub. You can go to github.com/hkirath/devops, Docker roadmap. Once you go here, you can see part 1, 2-solution-1. If you look at the Docker file here, you will notice it has 1, 2, 3, 4, 5 steps. I copy over package.json first, and then I copy over rest of the files at the very end. You can also see it here. I first copy over package.json, I then copy over the rest. If I run docker build, let's call it test1. If I run this build once, let's see what happens. As you can see, it says step 1 by 5, getting image from Docker. It is cached, even though it does not say it is cached. It is cached because it cannot so quickly bring the 1 GB Node.js image to my machine. 2 by 5, it is cached. 3, 4, 5 are not cached. Let me run this again. Now you will see 1 by 5 is also cached, even though it does not say it. 2 by 5 is cached. 3 by 5 is cached. 4 by 5 is cached. 5 by 5 is cached. Everything is cached. That's why it happens so immediately. Let me change the index.js file. Just remove a few spaces here. Let me rerun docker build. Oh, sorry. Let's do that one more time. Let's change index.js again. Let's rerun docker build. First is cached, even though it does not say it. Second is cached. Third is cached. Fourth is cached. Fifth is the final layer, is the one that's not cached. This is significantly different from our original approach from last video. If I go back to part 1 simple app, and here if I run docker build, let's call it test2. Let's run it once. Few are cached, few are not cached. Let's run it twice. Everything should be cached. We have not changed anything between the last build and this build. 2 by 4 is cached, 3 by 4 is cached, 4 by 4 is cached. Let me change index.js. I've modified index.js, added a few spaces there. Let me rebuild it. What does it say? 2 is cached, 3 is not cached, 4 is not cached. So 2 steps are not cached, and more specifically, a very expensive step, which is npm install, is not cached. This is the reason that if you move npm install up a bit and bring down copy ... your life will be super sorted, because you can save what layer changes most often. Most often when your code base is changing, only the index.js file is changing, package.json is not changing, which is why most of the times only 5th layer will rebuild. Of course, there will be times when you add dependencies and then 3, 4, 5 will be changed, but most of the times the changes will happen in the application logic, which is the index.js file or a bunch of JavaScript files that as your project grows, it will have. Package.json does not change very often, which means this layer won't change very often. That's sort of the benefit of creating a Docker file like this rather than creating a Docker file the way we did in the last video, where we were first copying over everything, then running npm install. Now we're just copying over package.json, then running npm install, then copying over the rest of the files. Cool. That is solution to assignment number 1. There was another assignment yesterday, which was कि भाई all of these images are very heavy. As you can see, all of them are like 1 GB or so. Does a Node.js application, does a Node.js runtime really need everything inside an Ubuntu machine, let's say? Or can it run in a more lightweight fashion? And the answer is it can run in a more lightweight fashion. You can always find, this is the solution for that specific problem. If you look at the Docker file, the first line has changed and it says from mhard/alpine node. For most libraries, for example, Golang, Java, you can find alpine versions of it, which are like much more lightweight. So if I now here run docker build with test3, and if I check the size of this new image, it's just 112 MB compared to the 1.1 GB. Does it still have the same functionality? It totally does. If I run docker run -p 3000:3000 space test3, it does run the app on localhost colon 3000. If I go to localhost colon 3000, I see the website. Cool. So that is how you can save a lot of space, which means save a lot of money if you're using Docker Hub. If they charge you for space, I think they do. So you can save like a lot of money if you bring down the sizes, and also save like a lot of build time, because this does not take too much time to download versus the node image, as you saw, is like 1 GB, so it will take a lot of time to download. Recap time. What have we learned until now? We learned about layers and how Docker uses layers to cache between builds. If you have a build 1, if without any change you run a build 2, every layer is cached. If you make some changes, some layers are cached, some layers are not cached, and you can basically try to push down the layers that are not cached to the very end. That way, the number of layers that are uncached can decrease in number. That is the practical way we saw this was by converting a Docker file to look something like this. As you have bigger projects, in case you add Golang to this project, the high level idea is okay, you first copy over all the files that contain your dependencies, then you run npm install or Rust cargo install, like what based on whatever language you're using, you install all the dependencies. At the very end, you copy over your source code, because your source code is the thing that changes most often. The dependencies don't change as often. If there are like 20 commits into the source code, then there is one commit to the actual dependency. So that's why you push down your source code to the very end, because source code is what changes the most. Whenever this changes, this layer will be rebuilt. All the layers inside it won't change, can be cached. Cool. Take a breather. You understand caching and layers, like a pretty advanced concept in Docker. Most people don't need to know about it. You just run like a bunch of Docker commands. But why is this beneficial? This is beneficial because you can now go to open source code bases and fix this for them. In fact, Backpack, I created the Docker files there, and someone actually created a pull request where they sort of fixed this and brought package.json up, copy.up, and actually sort of fixed this specific issue. So these issues do exist in open source code bases. I myself left them in Backpack, and people came and fixed them. So you can always like optimize Docker files and explain your reasoning as to why you're doing what you're doing. And it's like a pretty decent contribution to make in an open source code base. Cool. We understand caching and layering. Feel free to pause, get some water, because the next concept is also slightly advanced, called volumes and networks. Okay? Let's get right into it. All right, so volumes and networks. अभी तक एक बार recap कर लेते हैं. What all have we discussed? We understand Docker, we understand containerization, we understand the difference between images and containers, we understand a basic full stack Node.js application. We're able to create a Docker file for it, build it, and optimize the Docker file so that it's the most optimized when it comes to layer caching, and you get a lot of speed between subsequent Docker builds. This is enough to be able to write Docker files, change them for open source projects, create them for your own projects. Now comes some slightly advanced concepts. We will try to understand what problems/shortcomings exist until this point. And then we'll try to understand how volumes and networks and the things that are going to come after this solve those specific problems. Okay? Let's get right into it. First thing we're understanding is volumes and networks. Before we start, you should know that there is one more use case of Docker. Docker does let you containerize your own applications, but it is also used to run databases, Redis, any other auxiliary service locally. You can run your source code just like we've been running index.js, but you can also run databases. In the last video, we ran the Mongo database locally. We did not play with it too much, but we were able to pull the Mongo image and run it locally. Similarly, there are like Redis images, MySQL images. Very smart people have written those. They're very well optimized images. You run a single command, get that image locally and start it up. Why is this useful? This is useful so that we don't pollute our file system with unnecessary dependencies. If there is an open source project that has 5 such databases, auxiliary services that it uses, you don't want to bring the open source project locally on your machine, then bring MySQL on your machine, then like MongoDB on your machine, Kafka on your machine. Bring all of these things. Then whenever you're done with the project, you delete the project, but you still have those auxiliary services running. If you use Docker to bring in Kafka to your machine, to bring in MongoDB to your machine, then you know that all you have to do is kill the container and then your file system is clean. You did not put all of those files inside your file system. And secondly, you do not have to go through the headache of understanding, okay, how can I install MongoDB locally on my machine? Everyone has different operating systems. You just ran a single command and that brought that specific MongoDB database, MySQL database, Kafka to your local machine. So what is the second benefit of using Docker? It is that you can bring not just someone's source code up, you can also bring these auxiliary services up locally. We can bring up and down databases, Redis, Kafka, and clean our machine whenever you're done with the project. This is the benefit of Docker. Where do volumes and network come into the picture, Harkirat? We will see very soon. There is one problem here. The problem is, I keep saying, why are we using Docker? We are using Docker because you bring someone's code base locally, you run Docker, it runs inside a containerized environment, you kill the container and you're good to go. But this is a problem for things like databases. If you're bringing a MongoDB database locally up with Docker, we want the local database to retain information across restarts. If I'm working locally on a project, I started MongoDB using Docker, I added some data in there in that specific database, I shut down my machine, I restarted the container. What would happen? All my data would be lost. This is a feature of Docker. It makes sure everything runs inside a containerized environment. If you ever bring down the container, all the data inside it is lost. Whenever you restart the container, you get a fresh container. This is problem number 1. Databases need to persist data. It might happen, okay, I bring down my MongoDB database. If I bring it back up, I want my data to be there. Secondly, we want to allow one Docker container to talk to another Docker container. This might feel a little counterintuitive / difficult, but bear with me for 1 second. If this is my Mac machine, if you might remember from yesterday, we ran one container, let's call it C1, that runs our index.js file. We were running another container called C2 that was running MongoDB. If you run Docker run Mongo locally, you will see MongoDB running locally. Let's do that really quickly. So you know how to start your index.js file locally. I'm not going to repeat that, but this is something we did yesterday. Docker run Mongo. We'll bring Mongo to your machine and start it locally. You should add a port mapping here if you remember from yesterday, but these are the logs from Mongo. How do I know Mongo is running? If I run docker run -p a port mapping from 27017 to 27017 space Mongo, if I run this command and if I go to MongoDB Compass, which is basically a visualizer for like a GUI that lets you see the data inside your database. If I open that and I try to connect to the localhost :27017 database, I do get connected. I do see a bunch of data here. If I click on create database and add like whatever a user's database, I am able to play with it locally. If I ever exit this container, which I just did, and if I refresh MongoDB Compass, I basically won't be able to connect to it anymore because it does not exist for me locally. This is another container that you can bring up. If I now open this, cannot connect. As you can see, it's stuck on connecting. The reason is I turned off the container here. So you can always like run these containers in like a single command, a Mongo container, a backend container. A backend container might need to talk to this Mongo container. How does it do that? Is where networks come into the picture. You might feel intuitively, Harkirat, this we have exposed on 27017. This was running on :3000. Can't it just connect to this specific container by having localhost :27017 as the URL, the MongoDB URL? And the answer is no, it cannot. Why? We will see very soon. But this is why you need networks. And why do you need volumes? To persist data across refreshes. If I restart Mongo right now, you will see that database went away, because anytime you bring down a container and you bring it back up, it starts with the fresh data unless you are using volumes. Okay? These are the two reasons you need volumes and networks. Now, let's go to the next slide. And let's first just understand volumes. What are volumes? Oh, oopsie daisy. Volumes are used for persisting data across restarts, specifically useful for things like databases. How do you create volumes? How do you run volumes? Again, you get very nice Docker commands. To create a volume, this is the command you need to run. Whenever you're running your image, you need to give some extra things here. We will see, before that we need to understand what exactly a volume is. So let's take a more practical example. Let's skip this slide for now. There you go. So if I bring a container up locally, this is my Mac machine, and I run, let's say, Docker run Mongo. What will it do? It will start a container here. But I want to make sure I can persist data across refreshes. For that, what I can do is I can create a volume. Before I start my container, I will create a volume. What is a volume? You can think of it as a logical place where you can dump data from a container. If you ever bring down a container, this logical space still remains until you actually bring down the volume as well. So what is a volume? A volume is a logical place inside Docker where you can put a bunch of data from the container. More specifically, you can mount folders here onto a volume. So anything that happens inside a folder inside a container gets sort of stored in this volume. How do you do that? For that, we need to go back 2 slides. The way to create a volume is this command right here. So what would this command do? Forget that we're building images, forget that we're running images. Just this command would, inside the Docker engine, create a volume called whatever, volume_database, this thing right here. Now what you can do is, whenever you're bringing up a container, you can be like, bro, Docker run port mapping Mongo, but one extra thing here, -v volume_database, which is this thing right here, needs to map to /data/db. Now what is /data/db? /data/db is where Mongo dumps its data. Whenever you run Docker run Mongo, the place where all the data is stored inside that container, if this is the container, that is the /data/db folder. This will be different for every database. For MySQL, it might be a different place. For Postgres, it might be a different place. Specifically for this Mongo container, whenever you put data inside the MongoDB database, this is where it gets dumped inside the container. Even if you run MongoDB like locally without a container, there is a folder where that data is actually stored, right? It's a database. It stores a bunch of your data in some structured format, but in the end, it is stored in your file system. Whenever you're using the Mongo image, the place where it is stored is /data/db. What is /data/db, Harkirat? It's basically, where am I right now? I'm in /user/kirat/project/100xdev/DevOps series, this thing right here. Let me run Docker run Mongo. After I run this, I'm going to go in another folder and actually try to see what's present here. That will give you a better idea of what this specific folder is and how it sort of stores data in there, specifically MongoDB. So this thing started on the left. Let's look at the containers that I have running locally. I just have one Mongo container running locally. Let me actually do something like this so you guys can read this. Go. So I ran Docker PS. That shows me there is one Mongo container running locally. I'm going to run a command here. Don't worry about what it does. This is a command that lets you sort of go inside the container, like SSH inside the container. As what is the command? Docker exec -it, the container ID which I got from here, /bin/bash. How it does it is a whole different story. But if you run this command, it gives you like a bash shell inside your container. So if I press ls here, I see what the container looks like from inside. So this is what the MongoDB container looks like. This is the mini machine running inside my machine. So if I press pwd here, it tells me I'm in /user/kirat. This is my Mac machine. If I press pwd here, it tells me I'm in / where is this? This is inside the MongoDB container. And if I go to /data/db, I can see this has like some data here. If I go to MongoDB Compass, if I connect to the localhost MongoDB, create a database here, add some data here to AHDHD. Some random data I'm adding to our database, don't worry about it. These changes that I've made have actually persisted where is this like stored in a structured format? In the file system inside this container. So now if I press ls, I see a bunch of new things have been added. I don't know if you guys can see it, but a bunch of new things are there. Let's see if I can actually, would be good to like compare sizes here, but I hope you get the idea. Okay, this folder, if I can somehow, whenever I'm bringing down the container, let me bring down the container. In this terminal above, I'm going to run docker ps. I got the container ID. I'm going to run docker kill container ID. If I run this, this container will go down. What if all the data that's present here was persisted somewhere even after I killed this specific image? So if I kill this image, as you can see, it exited out of this because the container is dead now. What if the data that was here could have been stored somewhere? That is what volumes provides you. Between restarts, if you specify, okay, bhai, /data/db of this container needs to be stored in a volume. Even if you restart, whenever the container restarts, it will still get that data from the volume. The volume is actually a logical mount to /data/db if you are starting your container using this command. How is this command different from the command that we were running? There's just one difference here, which is this line. Okay, rather than running docker run -p mongo, I'm saying, bro, volume database, the thing that I created in the last slide, please mount it to /data/db so that all the data that's here, /data/db, as the MongoDB data changes, it gets stored in this volume _ database. And if I bring down the container, bring it back up, this again still remains mounted, which means my data still persists. That is what volumes provides you. And what is the way to create a volume? From the last slide, this is how you create a volume. This is the command that you run to actually start your MongoDB container, but with its data mounted to this volume that you created in the last command. Let's go to the next slide here. Let's try to understand this through this diagram and like a bunch of commands, and then let's try to run this locally as well. So let's create a Mongo container here. Let's simply run docker run -p 2717:2717 Mongo. This should start a MongoDB container, and once it does, I should be able to put some data inside it using MongoDB Compass. I connect to localhost. I create a new DB, call it test. I see the test database here. The problem is, if I bring it down and bring it back up, the test database is lost because we brought down the container, brought it back up. Now let's first create a volume. The way to do that is docker volume create, name it anything. I'm going to name it volume 3. And that creates a volume. How do I know that a volume is created? I can actually do docker volume ps or ls and see all the volumes that I have currently on my machine. I have a bunch of them. But the important one that I just created is this volume called volume 3. This persists until I actually delete the volume, which I'm not going to right now. I have the volume. Now when I start Mongo, I'm going to run docker run -p Mongo, but I'm going to add one more argument here, -v volume 3 / data/db. I think that was that's where the data is stored. So this is the extra thing that I add now. Let me press enter. Now let me open MongoDB Compass. Let's open a fresh version. And let me connect to this local MongoDB store. Let me add a database here. Call it test. Let me also add some data to this test database. I have some data in the test database. The database has a test table which has some data. Let me bring down the container. The container has stopped. How do I know that? If I run docker ps, I see no containers are running. If I run docker volumes ls, I still see volume 3 there, which means that data is still there. If I rerun docker run for Mongo on this specific volume, if I close Mongo and if I rerun it, now I will see data from my last run there because it's still present in this volume 3 right here. That's where my current container got the data from. If I go here, as you can see, test still exists. Inside tests, I see the data that was originally there. If I take this down and I remove the volume argument, what do you think will happen? Now, I don't have any data there because I have no longer mounted my Mongo container to that specific volume. So if I open MongoDB Compass now, what do you think I should see? Basically see empty data or like a fresh database. And that's exactly what happens. I don't see anything here. If I remount it, what will happen? I will again see the data there. So if I refresh this, as you can see, test came back. If I remove this, then test will go away. Cool. So those are volumes. Let you persist data somewhere till the time you have the volume here. You can keep mounting your containers to it, like a specific folder there, to that volume. And why is this useful? Mostly specifically useful just for things like databases, for Redis, for maybe even Kafka, not for your backend service usually. But for auxiliary services like these, you most of the times have a volume where the data is finally persisted. That is what volumes are. Let's move to the next slide. Yeah, if I kill the volume, I can also remove the volume. If I do kill the volume and also kill the container and remove the volume, then everything is gone. But if I don't remove the volume, then the volume is still there. Cool. Let's move on to networks. Take a breather here. You now understand volumes, hopefully. The next big thing is networks. Let's go back a few slides. What did I say? Why do you need volumes and networks? There were two problems. The first problem was we wanted data to be persisted across, we want local database to retain information across restarts. If you bring down a container, bring it back up, the data should be retained. We saw how you can do that using volumes. The second problem was we want to allow one Docker container to talk to another Docker container. So let's do a small thought experiment here before we proceed. Whenever you're writing the backend of your full stack application, you won't just have the application code running here. You will also have, if this is your browser that talks to your backend code will usually store data in what's called a database. You might have heard of what a database is. There are multiple types of databases. MySQL is a famous one, MongoDB is a famous one, Postgres is a famous one. And what do they let you do? They let your backend application store some data inside this thing called the database. Why are they useful? If you go to facebook.com, if you go to google.com, or if I'm on GitHub right now, as you can see, I see my data here. I see my profile name, it says Harkirat, Hkirat. All this information is stored somewhere, and it is not stored on the backend application. It's not stored in the same place you see express.js. It's actually stored in something called databases. MongoDB is one database. There are a bunch of other databases. And what is their goal? Their goal is to serve the backend code right here. More specifically, their goal is the backend code needs to store some data here, fetch some data from there. This is the permanent store for that. Backend servers go up and down, can always go down. Some outage happened, a new server comes back up. This is how auto scaling systems work. but the database is always persistent. Database always needs to be there. You usually have some clustering here as well, where you have multiple replicas. Okay, in case one goes down, goes corrupt, you have the data in other places. But at a high level, databases are very permanent. However, backend services, the code for which you see right here and right here, those servers can go up and down, which is why the database needs to be very securely placed somewhere. What are we trying to do? We are trying to start the database inside a container. Let me undo this a bit. Start the database inside a container, start the backend application inside the container, and make the backend container talk to the database. That's the thing that we're trying to do. For that, I've written this code. I've said the backend server should get the Mongoose library. This is a library similar to Express. Express lets you create HTTP servers. Mongoose lets you connect to a MongoDB database, put data there, get data from there. I import it here. I basically tell it the credentials to my MongoDB database. Now I'm just running a local MongoDB, which is why it says localhost :27017/my database. So it's like a very simple string. In production, this has like secrets here, username, password, all those things. But since I'm just running it locally for now, I say mongoose.connect. This is the place where you can find my database, which is running where? It's running here. As you can see, it says docker run -p 27017 to 27017, which means localhost :27017 on my Mac machine is running a MongoDB database. How do I know this? If I go to MongoDB Compass, when I was in the original screen here, I could see localhost :27017. This is what I was trying to connect to, MongoDB :/localhost :27017. If I connect, I see a database. I can put data here. I can take data from here. I can delete data, update data. Same thing I can do from here. This also has access to that username or that specific URL. And this has a library or uses a library called Mongoose, which lets you do the same things as this guy. This GUI can update data in your MongoDB database that's running locally right here. This code can also update data in this MongoDB database. How does it update data? If you look at it here, we number one connect MongoDB to the local MongoDB that's running here. If I change this URL to a production MongoDB server of mine, that is where it will connect and that is where it will store data. I create something called a schema, which basically means what is the shape of my data when I put it inside my database, and I say, okay, my schema has two things, text and a date. Text is a string and date is the current time of when this entry was put inside the database. Okay? So this schema basically represents, if I go to MongoDB here and if I try to go to, let's say, create a test database. So I write test here, that's my test database. This guy connects to another database called my database. You can basically change what DB it wants to connect to. It's like depends on you what name you want to give it to it. Here, if I want to add some data, let's say the shape of my data looks something like this. It's ignore the ID for now, but other than the ID, let's say the shape looks something like this. Text, which is a string, and date, which is whatever, 1st Jan 2023. If I want to put data like this into my database, as you can see, I just put like a text and a date here. I just described that schema over here so that when I'm putting my data inside, Mongoose can do some validations and make sure I'm following strictly this schema and only sending that to the database. This is one way to put data in a MongoDB database. There are a bunch of other ways. It's like the simplest one, which is used Mongoose. And how does Mongoose work? It expects you to create the schema. It expects you to give it the URL of the Mongo. And finally, inside my /route, which means whenever a user hits localhost :3000, control reaches here, and what do I do? I create a new entry, const entry equal to new entry. I pass in the text here, and I do entry.save. Now, if you don't understand what await is, if you don't understand what async is, it's fine. It's JavaScript specific logic. Feel free to ignore. What you need to understand at a very high level here is, okay, now whenever someone goes to localhost :3000, an entry will be made here in a database. How is that happening? The route that handles / captures this request actually puts something in the MongoDB database, which is why if I exit this out, feel free to pause here and read through it yourself. If I exit this type node index.js. Before that, I need to do npm install. If you're trying this locally, you will have to do the same thing. If I run node index.js, and if I go to localhost :3000, you will see it says entry added. If I keep refreshing, it keeps saying entry added. If I go to my MongoDB database and I refresh it, you see a new database created here called my database. And if I go to entries, this is an entry, this is an entry. These are all the entries that I just created. How? Every time I visit this, a new entry is created here. How? Whenever I am visiting this, the control is reaching here, this try statement. And what does this do? It creates a local variable called entry, and entry.save actually puts it in the database. If I change this from whatever, this is an entry, to this is an entry by Harkirat, and if I restart this, now if I go here and I go to MongoDB database, if I refresh, the last entry you will see here says this is an entry by Harkirat. There's only one such entry. Everything else says this is an entry, this is an entry, this is an entry. If I refresh again, I will see two values that say this is an entry by Harkirat, this is an entry by Harkirat. So that's the high level of how you can create a backend application that talks to a MongoDB database. The MongoDB database right now has been brought up inside a container. If I run docker ps here, you can see there is one container running with this ID, which is the Mongo container. The backend code isn't yet running inside a container. The backend code is running natively on my Mac, and that is the reason that my backend container can actually talk to this MongoDB which is running inside a container. The reason is, if this is my Mac, my backend is running natively here, the database is running inside a container, but since the backend is running natively, it can actually connect to localhost :27017 where my database is running. It becomes a problem when my backend and this is a container which is running the backend, this is a container which is running the DB. Now if I try to connect to localhost :3000 from this container, it won't be able to connect to this database. Why? The answer is, each container has its own network. I've repeatedly said this, every container has its network, it has a file system, it has a network, it has your files. What is a network? What do I mean by a network? Let's dive a little bit deeper into that. When I'm on my Mac and I go to google.com, I see something here. Under the hood, what happens is something called DNS resolution. Some of you might have heard of this. I'm introducing a new term here. What does DNS resolution mean? It means my browser converts this google.com into an IP. It is similar to if you're on your phone and you save your friend's number as their name, for example, let's say Raman. I just click on Raman, but under the hood, the call is going to 8971 some number. Similarly, in your browser, you write google.com, but under the hood, a request goes to some what's called an IP, which looks something like this, if you might have seen it, 12.3.44.5, something like this. This is one IP. There are multiple IPs. Like every domain name that you see has an underlying IP. And how can you find the IP of a domain name? There are multiple ways. One way to do is use the ping command. So if I write ping google.com, as you can see, it says this is the IP of the Google server. When I'm calling someone, the phone number is where the call is going. When I'm going to google.com here, this IP is where the request is going. This is basically the IP of that Google server that I'm hitting, that is giving me back some HTML. This is the network. This is not exactly this. This is my machine, my Mac, talking to Docker. My machine has a network of its own itself. What do I mean by that? Basically, up until now, we've been going to where? Localhost :3000. What is this localhost? This is also a domain name, very similar to google.com. I can actually do ping localhost and it will give me back something. It says localhost points to what? 127.0.0.1. If you remember index.js, I write localhost :27017. This is similar to me writing 127.0.0.1 :27017. So that IP and the DNS are the same. My machine's localhost, my machine's 27017 points to my Mac address, my MAC's sort of local address. But if I'm inside a container and I write localhost there, or write 127.0.0.1 here, that means this container's internal address, not the Mac machine's internal address. Which means if I have a backend container running here and the backend container tries to visit localhost colon 27017, it will try to find something running on this port on this container. But where is MongoDB running? MongoDB is running in a different container on the same machine. So we need to connect both of these containers somehow. If I run ping localhost here, if I was able to run ping localhost here, this would tell me I'm still pointing to 127.0.0.1, but for this machine it means this specific container. For this machine it means this guy. Every container has its own network, which means inside every container, localhost means the same container and not the parent machine. The parent machine has its own network. Each container has its own network. Parent machine can route requests inside a container. A container can't really go outside. There are ways to do it, but like you don't really make the container go to the host machine / access services on the host machine unless and until, again, there are ways to do it, so don't quote me on this, but usually how does it happen? If there are two services that you know need to talk to each other, let's say the backend service and the database, you create a network between them. That is what networks mean. Cool. Time to pause here. What have we learned? After learning volumes, we reach this new section called networks. What did I say? I said, bro, MongoDB now has a volume. I showed to you guys, okay, let me run node index.js here. When I run node index.js, I can go to localhost colon 3000. My backend server can talk to this Docker container. But if I build a Docker image here, if I run, let's say Docker build test4 dot here, and if I try to run Docker run 3000 test4, it runs. If I go to localhost colon 3000, the request gets hung. Why? Because this guy, this container that is running now, can't talk to this container. How many containers do I have running right now? Let's not do it here. Let's do it here maybe. I have two containers running, the test4 container and the Mongo container. They cannot talk to each other. More specifically, test4 is trying to connect to localhost colon 27017, but nothing is running on this container's local host. Something is running on a different container's local host, but they cannot really talk to each other until and unless you introduce networks. As you can see, I started the container, but the container stopped. Container said mongoose connection error, connection refused, nothing is running on 127.0.0.1 colon 27017 because nothing is running inside this container on 27017. What is something is running on 27017, but it's on a different container. I need to change index.js. I need to replace this localhost with something else. I need to say, bro, on the Docker network, find the Mongo image and try to connect to it. So the final IP here won't be 127.0.0.1 because 127.0.0.1 is that container's IP, and this guy is not running MongoDB, it's running in a separate place. Let's go back to the slides now and try to capture everything in a more visual format. I have a backend, I have a MongoDB, I have volume. These two are containers. This is a Docker volume. This should be my final setup for a very nice backend application. The problem is containers have their own networks. What is a network? 127.0.0.1, the thing that we just saw. Every machine, if you type, oopsie daisy, if you type 127.0.0.1 in any machine, that means the address of that own machine or container. If I run ping localhost on the Mac, that means it will try to find that MAC. If I go to 127.0.0.1:3000 on a Mac, it will try to find what's running on port 3000 on this Mac. If I go to similarly localhost :3000 on the Mac, it will try to find something that's running on the same Mac. However, containers are mini machines. They will try to do the same thing. They will try to find a service running on, in this case, port 27017 on this container, but there is nothing running on port 27017. On this container, it's actually running on a different container. So localhost in the context of every container means itself, which means I can't simply be like mongoose.connect localhost :27017, because localhost for this backend application means the same container. I cannot do this. One container cannot talk to the host machine or to another container. Whenever I write localhost here, it tries to talk to itself. I write localhost here, it tries to talk to itself. I write it on the Mac machine, it tries to talk to itself. When we run docker run with -p 3000:3000, the Mac machine routes the request to the container, but the first request does reach the Mac machine. Okay? So this is a brief of what is the problem that networks try to solve. How can the backend talk to MongoDB? The answer is networks. Let's update the backend and put some data in a MongoDB database. We already saw this. You saw the updated backend. The updated backend now has some code that puts some data inside a MongoDB database. Let's introduce a network. For one container to talk to another container, we need to give them a logical binding, which is called a network in this case. The way to introduce a network is fairly straightforward, just how we created a volume. We need to create a network, and when we are starting the containers, we need to specify that this container is running in this network. Once we do that, one service can talk to another service by hitting a certain IP or a certain URL, which you will see very soon. But at a high level, what do we need to do? We need to first create the network. Let's do that. Let's go to the machine and run docker build, docker volume, network. Create, and let's give it a random name. Let's call it network 5. Now if I run docker network ls, it gives me my network 5 bridge network that I just created. There are a bunch of networks, like bunch of types of networks. This is the most popular one, a bridge network that I just created. What I've done, I've just created a network. I haven't yet started any container that connects to this network. I've just created a network. Let me go back to the slides. What is the next step? When you are starting, you run docker run the port mapping. You give it a name. This is something new. Why would we give a name to a container? And the answer is, this name is how one container finds the other container. So this part is important. You need a name, you don't need a name, but if you don't give it a name, it will get a random ID. So it will be very hard for one container to find the other container by a random ID, which is why it's a good idea whenever you're connecting a Docker container to a network, which is something we're doing here, give it a name as well. Give your container a name. Okay? So it's the same command. What are the extra things? One, we have given it a name. Two, we have attached it to a network. And then finally, the image tag, just how we did until now. So let's start that. Let's now start the backend with two extra things. After -p, what will we add? We'll add -- network, network 5, and we'll add -- name, let's call it backend 2, enter. Already has a name, so let's give it a backend 10 name. There we go. I started a container. I attached that container to network 5 and I gave it a name called backend 10. I did not need to give this guy a name. I actually need to give the other guy a name because this is trying to connect to MongoDB. So this guy needs to know the name of the other guy. The other guy doesn't really need the name of this guy, but it's still fine if you want to just name this specific database, this specific backend process. If I run docker ps now, it says I have a test4 container running. I have a Mongo container running. This is where test4 is running. This is where Mongo is running. Let's shut down Mongo. Let's restart Mongo only. We give it two new things, a name, let's call it MongoDB2, and let's give it a network, which is the same network as before, which is network 5. So the same command, but what are the two things I've added? One, I've attached it to a network. Two, I've given it a name. The name I'm giving to this guy is MongoDB2. Press enter, it starts. So if I run docker ps, how many containers do I have running? I have Mongo running. The other one stopped because again it was not able to talk to this container. So last question is, what should this URL be replaced with so that this guy can talk to this guy? And the answer is, if they're in the same network, which we are going to start them in the same network, localhost should be replaced by the name of this container, which in this case is MongoDB2. If I put MongoDB2 here, just how if I do ping google.com, it resolves to this IP. If I ping localhost, it resolves to this IP. If I go to this container and try to ping MongoDB2, the IP that comes back will be the IP of this container. That is how this container can now talk to this MongoDB container, because MongoDB2 would resolve to an IP of this specific container, the MongoDB container. Let's save this and let's run this again. Docker run. Everything is the same. Let's rename this to backend 20. You don't have to give it a name. So let's just not give it a name. The backend doesn't need to have a name. This guy needs to have a name because backend needs to connect to this guy. So let's remove the name here. Let's just specify the network and press enter. Now if I go to localhost :3000, hopefully this guy has a connection to this MongoDB now, because one, they're a part of the same network. This guy says -- network 5. This guy also says -- network 5. Secondly, inside the index.js file here, I replace the MongoDB URL. I replaced localhost with MongoDB2, which is the name of this container. And inside the context of this container, that resolves to, it should have resolved to this guy. But there is a problem here. The problem is I probably need to delete this image, the test4 image. Yeah. Do it again. There you go. Just need to build the image again. I forgot to do that. Since I did not build the image, the new updated code did not reach the image. I just need to rebuild the image, and now need to, oopsie daisy, I ended up closing it. Where was I? I was in part 2-1 complex app. Let's call docker run again. That looks right. And now this container, the index.js file here, if I cancel it, I'm not able to cancel it, never mind. Let's go to localhost :3000. As you can see, it says entry added, which means this container can now talk to this container. But why is that happening? Because if you go to the index.js file here, the index.js file here now has what? MongoDB2 as the URL, which inside the container will resolve to the IP of this container. That is why /how this container is now able to talk to this container, which is exactly what I was showing in this slide. There is a network that connects both of them, this network right here. Alright, so with that, hopefully you get a decent idea of what are networks and why you need them when you have a bunch of independently running containers that need to talk to each other. With that, let's move to a quick recap of what we have learned until now. Since the beginning of the video, we learned a little bit about layers and caching, and after that, we discussed volumes and networks. The problem that we wanted to solve was, one, we want local databases to retain information across restarts. For this, we use volumes. We create a volume and we tell the MongoDB container, okay bro, put all of your data here, not exactly put your data here, but like mount a specific folder inside you to this volume. So even if your container goes down, bring it back up, mount it to the same volume, and the data retains there. Secondly, we wanted to allow one Docker container to talk to another Docker container, and for this we introduced networks as long as they're both started with the same network, and as long as they're started in the same network and one container wants to talk to the other one, it can simply reference it by pinging the name or sending requests to the name of the other container. The name of the other container is what will resolve to the 2.3.5.23, let's say, the IP of the other container. If you have a container 1 and a container 2, if in this first container I run ping name of the second container, this ping command will resolve to an IP that looks something like this, 2.3.5.7, whatever, which points to the IP of the other container. That's how container 1 can talk to container 2. Cool. This is a quick recap of what we've done until now. Next, we're going to understand something called environment variables. The reason we need to do this is because a few things are coming from now, so it's a good thing to know. These are very language independent. These are also like Docker independent. There's generally things that you have when you're writing backend applications, even front-end applications for that matter. So let's understand what are environment variables and why you need them. The problem is that it's difficult to keep editing files. As you just saw, if I wanted to change the MongoDB database, I basically went, let me just clean this up a little. I basically went inside the index.js file and I replaced the MongoDB URL here with MongoDB 2. What if in production there is a different database? What if when I'm running this application in a dev environment, a prod environment, a staging environment, I basically need to keep editing these files, and that's bad. More importantly, you should never check in database URLs. This is like something you should ingrain in your mind. Okay, you should never check into GitHub a URL, a secret that contains the credentials of your MongoDB database. Again, here it's as simple as localhost colon t 2717, so it doesn't matter. But if I had a real MongoDB URL here, if I would push it to GitHub, it would be a problem because everyone all around the world can look at that URL and connect to my database. Lastly, environment variables are a language independent construct that lets you send secrets to processes. This is one thing that environment variables provide you. They provide you a bunch of other things, but the most important thing they provide you is, okay, whenever you have an index.js file and you know there is a secret there. What do I mean by secret? A database URL, the credential to your, let's say, an AI API company API, the credentials to your Kafka instance. Whenever you have this, rather than hard coding it here to whatever localhost colon 27017, write something like, for Node.js, process.env dot, let's say mongo underscore URI. This is what's called an environment variable. More specifically, this is how you access environment variables inside Node.js. Every language provides this. So Golang, inside Golang also you can access environment variables, inside Java as well. This is how you access them inside Node.js. And why is this cool? Because if I save this file, or if you just go to 2-env variables here, you'll basically find the same thing. If I go to do a index.js here, you will see I'm not giving an explicit URL here. I'm saying process.env.mongo URI, and then I'm also logging it right below it. That's how you access an environment variable. How do you send an environment variable here? Using, you can do a bunch of things here. One way to do it is mongo URI equal to whatever, let's say localhost node index.js. If I run this, you will see the log said localhost. This is an incorrect MongoDB URL, which is why there's an error here that says the connection should start with mongodb : // But this is how I can pass an environment variable inside a JavaScript process, or more specifically a Node.js process. Similarly, you can do it for other languages as well. And why is this cool? This is cool because now in my index.js, I just have this, and whoever is starting this process will inject the right environment variable. So if I start this either natively like this or using Docker, I can inject a MongoDB URL inside using environment variables rather than going to the index.js file, editing the index.js file, changing that specific string, coming out and then starting the Node.js process. So hopefully it's clear as to why you need environment variables. Again, pretty language independent concept, a few of you might already know it. And what is happening at a very high level, rather than writing a URL here and keep changing it based on whether you're starting it in a container, whether you need to access MongoDB through a network or on the machine or to a production database, rather than keep editing this file, you simply write process.env an environment variable name, which in our case is mongo_URI. And when you're starting the container, this is how you can pass the MongoDB URL inside, -e mongo URI equal to whatever is your final MongoDB URL. So if you are connecting, if you are using networks, and if you have your backend container and your database, and the name of your database, let's say is Mongo, then you can simply pass in mongo_URI equal to not exactly this, something like MongoDB://mongo:27017. So you can pass this, inject this environment variable from the outside rather than hard coding it inside the URL, inside the index.js file. So if I had to start this, what do I have to do? It's the same thing as before, docker run -p 3000:3000 -e mongo_URI equal to, let's do localhost test. I have to build it first. Let's first build it, docker build test1 dot, first build the image. After you've built the image, run the image with the right environment variable. You should run it with the right variable. I'm just showing you how this works. So I'm just giving a dummy environment variable here. And when I press enter, you can look at the logs and it says localhost test is the first line that is logged, which is the process.env.mongo_URI that is logged where? Right here. So this log inside the container points to what? Localhost test, which is what we've passed here as an environment variable. Why is this useful? The reason this is useful is all your secrets should never be hard coded in a .javascript file. They should always be accessed via environment variables. And this is the way to do it in Node.js. Cool. Multi-stage builds. Now comes a very big checkpoint/thing you need to know. And before we start this, you should learn a few Node.js specific things so that we understand the real use case of multi-stage builds. Cool. Two things we have to understand. First thing, so forget about multi-stage builds, this heavy word that we just introduced. Let's focus on thing 1 and thing 2 here. It says scripts in Node.js and the NodeMon library. A few of you already might know this, so feel free to skip it. Let me go back to 3-NodeMon here. Feel free to go to the same folder. And let me do two things. One, let's explore package.json here. You will notice along with Express and Mongoose, I've added a new dependency called NodeMon. And what is this dependency? It is similar to the node command, only if rather than doing node index.js, I do NodeMon index.js, or more specifically, I'll have to do npx NodeMon index.js. You will notice some extra logs along with example app starting on port 3000. And what is cool is, if I go to this same file in a different folder and try to edit it, add a few spaces here, as soon as I exit this edited file, you will see the server restarts. So what does NodeMon let you do? When you start an index.js file using not node but NodeMon, it watches your index.js file, and any time a change is made there or any transitive file that is imported by index.js, the server will restart. Why is this useful? This is useful during local development. Okay, when you're developing code locally, if you edit a file, you don't have to stop the process and restart it. If you have NodeMon index.js running, it will just keep restarting itself. That is thing number 1. Thing number 2 is the scripts section in our package.json. If you look at our package.json, it has a scripts section which has two things, start and dev, This is pretty much nothing. It basically means that if I am in this folder, and if I run node index.js, it is the same as me running npm run start, because in my script section I've said start points to node index.js. So if I run npm run start, it is the same as me running node index.js. If I press enter here, you see the same log, example app running on port 3000, example app running on 3000. Similarly, there's another script here called dev. If I run npm run dev, it runs the same thing as node mon index.js, which basically starts your backend server, and it also watches your index.js file. So if I edit the index.js file again, you see the server restarts, even though what process did I start? I did not do a node mon index.js, I did a npm run dev. Cool. These are two things I wanted to introduce, very Node.js specific things, or like things that npm provides you. You don't, like, it will be different for a different language, but you need to know this before we go to the meat of what we're discussing today, which is multi-stage builds. The reason for that is, question is, why do you need multi-stage builds? What are multi-stage builds? What if you want to allow the dev backend to hot reload, but the prod environment to not? What do I mean by that? Firstly, what are environments? Dev environment basically means whenever I'm running this code locally on my machine, which means node index.js, that is what you can call a dev environment. But when I deploy this on the internet on an AWS machine, that's running in production, real users are hitting that. That's the difference between dev and prod. And usually when you're running a process locally in dev, this is the command that you run, right? Because you are quickly editing the index.js file. Whenever you make an edit, you want the thing to hot reload, which means you want the server to, not exactly hot reload, but like the server to reload automatically. That's probably a more technically right term. You want the server to restart automatically. You don't want the same thing in production. What's the problem if I run node mon in production? There's no real problem in this case, but there are a bunch of more optimizations that you do. You basically need to have two separate scripts that run on your machine and on an AWS machine. If I go to package.json here, I have defined two separate scripts, the start script and the dev script, and both need to do two separate things. This is the script that you run when you're developing locally. This is the script that you run on production. The question is, how do I write this in a Docker file? If you look at the Docker file right now, the last command is npm run dev. So this works well when I'm working locally. But when I deploy this on the internet somewhere, I want the final command to be not npm run dev, but npm run start. How do I make sure that npm run start runs there? Should I create another Docker file here? Should I be like, okay, copy Docker file 2, and in this Docker file 2, I replace the final command and then I run the Docker file 2 there? Or is there a better way? And the answer is there is a better way, and that is what multi-stage builds are. If this, so look at this Docker file. This is the final multi-stage Docker file. In case you need to have a single Docker file in which you can, if you want to run it's differently based on whether it's running in a dev environment, which means locally on my machine, or in a prod environment. Let's see what extra things we've added, what is different here from our original Docker file. So what was our original Docker file? Our original Docker file looked something like this. As you can see, from node 20, this is the working directory, copy over package.json, run npm install, copy over the rest of the files and expose this port, run npm run dev. Ideally, I want something like this, like if environment equal to dev, then run this, else run whatever, npm run start. You want something like this, but this is pretty ugly. So rather than writing this, what do we write? We write something like this. We say, create image number 1 from here to here, from Node.js as base, which basically means create a base image, call it BASE base. What will this base image have? It will have Node.js as the base image, have this working directory, copy over package.json, run npm install. These 4 steps will create a single base image. Then it says, from base, which means taking this as the initial point, create another image. And what should the other image be? It should be the same image, only it should copy over the rest of the files and then run npm run dev. That's the dev image, or more specifically the, oh, oopsie daisy. Base image, dev image, production image. In the same file, I said, bro, you see the from keyword thrice, which means you are creating 3 images. Only image number 2 and image number 3 use image number 1 as the base image. As you can see, from production as from base as production, from base as development. Image 2 and 3 use image 1 as the base, and this are things that you can run independently. And based on whether you're on a local machine or you're on a remote machine, you can just basically flip the docker run command a little bit or docker build command a little bit, and that will build either the dev thing or the prod thing. npm run dev is something you want to run when you're running this locally. npm run start is what you want to run when you're running this on a global machine. So what are the 2 different commands that I need to run? This is how I will build dev, which basically means this is how I will run this locally. The docker build command, along with the standard things that we had, has one extra thing here, -- target development. So let's try to run that locally. When I want this to keep hot reloading and run npm run dev locally, what do I have to do? Docker build -t, let's call it app dev dot, and what other argument do I need to give? It is the target, which in this case is development. Am I in the right folder? I am not in the right folder, because the docker file here is incorrect, it's stale. So let me go back. If I go to 4- multi-stage builds, and if I open the docker file here, this is the right docker file. So here, if I run docker build dot -- target development, this is the only extra thing I've added. I tag it with app dev. If I press enter, this will build my development image, which means it will build this thing right here. Now this thing does use this, but overall these are the steps that it will run. Step 1, step 2, step 3, step 4, step 5 and step 6. This is how my image will be made. And if I go here and if I run docker run app dev, you will see the logs would represent that of nodemon, which means nodemon is running, which means npm run dev is running. There are some changes we need to make here, but at a high level, this is how I started one environment of my docker file. How can I start the other environment? Let me kill this environment, kill this image container. I have to be technically right. And let's start production now. How would you start production? It's basically the same thing. Rather than basically the same command, but the environment, the target will be production. And let's call this image app prod. And when you're running it, you can just run. I mean, you should pass the, so if you go here, you'll see I do a docker and I send the right environment variables, port mapping, all that jazz. But just to like show this locally really quickly, I'm just going to do docker and app prod. That should start your production, which means this should run npm run start, as you can see, which means this is not using nodemon. Now this log's undefined. I don't have the right MongoDB URL here. But if I had the right MongoDB URL here, this would just work. If I just pass that as an environment variable. And that is how you can run, oh, oopsie daisy, I'm sharing the wrong thing, I think. So let me just repeat this part. Docker build command to build the production target, which means this thing right here. So the number of commands will be these 4 commands followed by these 3 commands. This part will be completely ignored because what target am I using? I want to create production. Production uses base, so it will start from here and then run these things. Secondly, after I have built this, I'm just going to do a docker run app prod, and that should start the thing. Only I have not passed in the right environment variables here, which is why You see undefined here, but if I do pass the right environment variables, it should be able to connect to MongoDB, all that jazz. We already covered that. So this is what is multi-stage builds. Only one small thing here to mention. I don't know if I have that in the slides. Yeah. Oh no, I don't have that in the slides. So let me just share that. There is one small problem here. Let me run app dev again, which should run npm run dev. As you can see, it does run npm run dev. It does use nodemon. But if I edit the index.js file here and exit, this doesn't hot reload. Why? Can you guess? What is the problem? In 4- multi-stage builds, I ran a Docker container that did run nodemon. But if I edit the index.js file here, this nodemon doesn't really restart. I don't see anything in the logs. However, I'll give you a hint. If I kill the Docker container and I run npm run dev here, and now if I edit the index.js file, you will see this reloaded. Why did it reload if I'm running it like this, npm run dev, but it does not reload when I run docker run app dev? If you look at the Docker file, you might be able to figure it out. The answer is, I copy over the files from my file system over to the image. I never edited the files inside the container. I edited the files outside. They have no wajud. After the image has been created, the image has its own index.js file. Outside here, I have my own index.js file. I could remove this index.js file. It would not affect the container. Container has its own index.js file. If I do something like this, let me run app dev, and then let me SSH into the app dev pod. Docker exec-it. Here, if I now edit index.js file inside the container, oh, it will be hard to do it. What's the other vim index.js? If I edit this file here, is when this will restart. Let me remove the file. Maybe that does it. I didn't do it. But you get the idea. If I edit the index.js file here inside the container, then nodemon will be like, okay, I need to restart. But if I edit the file on the file system, nodemon won't restart. That is the problem. What is the solution? Can you think of it? This is something we have covered today. How can I make sure that if a file is edited here outside the container, does the container restart? I will repeat. If this is my Mac machine, this is a good assignment. This is my Mac machine. I have an index.js file here, and I have a container running which has its own index.js file. It has a copy. How can I make sure if this thing is edited, nodemon here restarts? If I edit the file here after going inside the container, nodemon will restart. But I want, because in the end, real developers will be using this project, real developers will start this locally, real developers should be able to edit the index.js file on their machine, and that should restart the container. How can I make sure if this file is edited, the container restarts? Think about it a little bit. We have discussed this. If you want a small hint, the hint is volumes. But we haven't exactly discussed this, so you may or may not be able to do it. Feel free to spend some time, ChatGPT it, and then come back to it. I'm going to share the solution. The solution is, this might actually be in the slides as well. Let's see. It is indeed. If you look at the slides, there was one more thing here along with the rest of the things. When I said start the Docker container, I said mount dot to /user/source/app. What is /user/source/app? That's my working directory. What is dot? This thing right here. What am I mounting? Until now, we created a new volume. And whenever we used to run the -v or give the -v flag, the thing on the left was not a path. It was the name of a volume. For example, we had like volume 5 at some point. Now I'm saying, okay, no, not a Docker volume. Literally this folder needs to be mounted to /user/source/app, which means if you add a file inside the Docker container, it will get added to your root machine. If you add a file here, it will get added here. These two become the same thing. You mount literally dot to slash user slash source slash app. And if I now run this command, so what's the command? It will be docker run -v dot colon slash user slash source slash app app dev. As soon as it starts, I'm going to edit the index.js file. And as you can see, the container restarted when I did. Why did that happen? Because now if I do a docker exec, now if I go inside the Docker container, I still cannot edit the file. But basically, okay, let's do this. Let me go inside this Docker container. Oh, see daisy. Inside the Docker container, I'm going to remove the index.js file. And then I'm going to exit. From here, I'm going to kill the Docker container. I killed the Docker container. If I go here, I don't see an index.js file here itself, which means a change that I made inside my container propagated outside to my Mac machine. Why? Because I explicitly said, I said dot and these are the same thing. This creates a mount to dot, which means if I delete a file from here, it will get deleted from my Mac. If this is my Mac machine, this is a container, this is my file system. I created a mount from here to here. Any file that I add inside this container will get added here. Any file that I delete from here will get removed here. Both are basically the same thing, which is why this is like very dangerous and you should keep in mind when you're mounting things like this. But since we're locally developing here, it is totally fine. And this is the final solution to the problem. If you want to have multi-stage builds where you want to allow developers to be able to run your project locally in a single command, what will be that command? The command will be, they'll have to build the Docker image, specifically the development target. So this is the first command that the developers that are trying to contribute to your project will run. After they run this, more specifically this, they need to run the docker run command. And after that, even if they're developing locally, they're in their VS Code, they edit an index.js file, their container will restart, node-mon will restart the container, and that's how they can basically quickly develop locally without having Node.js locally, without having any other dependency. They just need to have Docker and they're good to go. And not hot reloading, but automatic reloading works as well. Cool. Decent checkpoint. We hopefully understand multi-stage builds now. The last big thing to cover is Docker Compose, and then we're sorted. So let's do that. Let's understand Docker Compose. Until now, there has been one problem. The problem has been our project has multiple dependencies. For example, right now we just have MongoDB and the backend. The problem has been, okay, I've always had multiple terminals open. I run MongoDB here using one Docker run command. I run the backend here using another Docker run command. What if I had 5 dependencies? I would have had to open 5 terminals here and run one Docker command here, one Docker command here, one Docker command here, so on and so forth. That sounds pretty ugly. As your project grows, you don't want that the developer runs 5 different Docker commands. You want them to run a single command. That is where Docker Compose comes into the picture. The name itself has compose in it, which means lets you compose a bunch of images / containers together. What is the problem we're trying to solve? A project has a lot of auxiliary services it needs to use. For example, MongoDB, Postgres, Kafka, MySQL. What is a bad solution to this? You can run multiple Docker commands. You can run them in multiple terminals or use detached mode. So one more important thing to understand is detached mode. It's pretty much nothing. Whenever you're running Docker run, if you don't want the terminal to hang here, if you want it to run in the background, you can run it in detached mode, which basically means you have to add a -d flag. When you do that, it will basically run in the background, so your terminal won't be hung here. As you can see, it says it is started. If I do a docker ps, I will see that specific container. I can check the logs of that container by doing docker logs container ID. As you can see, I can see the logs. But this is cool. This is cool because now you don't need multiple containers. I ran the first command. I could run the second command to start Mongo, and then one more command to like with in detached mode, and then another to start Kafka, so on and so forth. You could do that, but this still is pretty ugly. You're expecting the developer to write multiple Docker commands to start the project locally. What if they miss one? That's bad. A good solution is Docker Compose. What does it say? Compose is a tool for defining and writing multi-container Docker applications. With Compose, you use a YAML file to configure your application services. Then with a single command, you create and start all the services for your configuration. Feel free to read it, feel free to marinate it. Long story short, you create a single file. That single file represents what all services you need. Is it Mongo? Is it MySQL? Is it a database? And your actual backend, your actual Docker file, you write that in a single file. You run a single command, it starts everything. The only new thing here might be, you have to describe this in a YAML file. So not a .javascript file, not a .json file, not a .golang file. It's a YAML file. So if you don't know what YAML files are, it's basically very similar to JSON files. So let's try to dive deeper into how you do this and what the final Docker Compose file looks like. Hopefully you guys understand JSON. This is not the final thing. You need to write a YAML file. You need to write a YAML file. This is a JSON file. But before we type into a YAML file, let's understand how you could write a JSON file if you wanted to simply describe the services that you need. Let's say you need a Mongo service, a MySQL service, and your main application service. You can write code that looks something like this. You can say, okay, bro, services is an object. Inside the object, I have 3 keys, a MongoDB key, a MySQL key, and a custom app key, which is my custom app or my backend application. I can write the image for those specific containers. I want to start MongoDB. Where can I find the image, or where can Docker Compose find the image for it? It can find it. Oh, oopsie daisy. It can find it here, which basically means get it from Docker Hub. Similarly, MySQL, get it from Docker Hub. Feel free to ignore this. This is an environment variable which sets the root password for SQL. You can also do the same for MongoDB if you want. Lastly, we say custom app, which means my own app. You can name it anything you want. For that, pick the code from the Docker file in this folder and have this port mapping in there. This looks like all of our Docker commands composed into a single file. Again, this is not the final file. The final file won't be a JSON file. The final file will be a YAML file. But just to understand this slightly better, hopefully you understand how in a single file you can write, okay, bro, I need 3 sources, MongoDB, MySQL, and a custom app. MongoDB, find the image here and run it. MySQL, find the image here and run it. Also pass these environment variables inside. Custom app, find it in this Docker file in the same folder that this compose file is in, and use this port mapping when you're starting the container. So hopefully this part is straightforward. But you don't really need a JSON file. What do you need? A YAML file. So here is a representation of the thing that's written on the right in the YAML format. There are very subtle differences. YAML does not have brackets. It has like these colons. So you say, for example, here we said services is an object. Here we say services has everything inside it, and everything inside is sort of tabbed to the right, which basically is similar to everything inside this object. So that's how you can convert sort of, or think of YAML very similar to a JSON file. Basically is a key value pair. This is the key services, and this is the value of that key, which is this whole thing right here. Similar to how services is the key here, and inside this object, this is the value of this specific key. So try to spend some time understanding YAML. Maybe look at a simpler YAML file. Maybe just ignore everything below it. Just focus on this bit. Services is a key. It has one, the value of it has one key, which is MongoDB, the value of which has an image and a port, similar to if let's say the object was much smaller over here and there was a closing bracket here. That way, try to map this file on the right to the file on the left here. Feel free to pause it. They're both the same, only the format in which they're written is different. The thing on the right is JSON, the thing on the right is YAML. Cool. Feel free to pause. There are a bunch of these ways you describe configuration files, but whenever you're running DevOps, the file is The final file is usually a toml file or a YAML file. These are just formats in which you can write key value pairs. The one that Docker Compose ended up choosing is a YAML file. It's very easy to convert from this to this and vice versa. Cool. Let's move on and let's see, given this YAML file, how can you run it locally? And the answer is a single command, docker-compose up. We still have to understand networks and volumes and how those happen in this file. But ignoring that, docker-compose up, a single command, will take this YAML file as an input and understand, okay, these are the Docker commands that I need to run, these are the images that I need to build. It will do everything locally and start your container. Let's try it out. Let's look at the code here. So if you go to 5 Docker Compose, you will see along with our Docker file here, which looks the same. We don't have npm run dev, any of those fancy things. We simply have node index.js. I have a docker-compose file. Let's look at the compose file. What does it say? It says, it's like a trimmed down version. We don't really need a MySQL here, so I removed MySQL. It says services, MongoDB, and custom map. MongoDB, get the image from here. This is the port mapping. Also has a volumes section, which let's trim this down a little to like keep things easy here. So let's say this is what this can be this is a pretty valid Docker Compose file. It does not have volumes yet, which is not great because what we're starting is MongoDB, which needs a volume. Does not really have a concept of volumes here, networks here either. But this is enough for you to start both MongoDB and your local app together in a single command. Let's try that out. Let's save this file and run docker compose up. Once you run that, if you go to the top, it says network something created. Why was the network created, Harkiyat? We will see very soon. Ignore this line. Other than that, it says container 1 created, container 2 created. It started 2 containers. If you look at the logs, it started MongoDB. You see a bunch of MongoDB logs. It also started your backend application. Why don't I see the logs here? Because maybe the backend application doesn't log anything. Let's see. Trying to find a log here. Let's add a log here. The backend application isn't logging anything. Hi from the backend application. Let's remove the images that we have. So remove it, maybe not. Let's see. Docker compose up. There you go. Along with the MongoDB logs, I see another log here that says example app listing on port 3000, which means our backend has also started. Both have started in a single command, and you see very nice logs here. When I ran the docker compose up command, it said container started, also started the network here. And when I stop it, it says container stopped. Cool. Question is, and this starts and this works, like MongoDB is running, the other thing is running. The backend is not able to talk to MongoDB yet because we haven't really introduced networks, or does it? We will discuss very soon. Secondly, we don't have volumes here. So let me just reset this file. That's right. That does look right. Let's also show you the same thing in the slides. This was the original Docker image that we had, where we had 3 services. How do you add volumes and networks to it? All containers are already connected via a network and can be referenced by their name. The special thing about Docker Compose is, whenever you use Docker Compose, if you have 3 services in there or 10 services in there, whenever you start, if you remember, we saw a log that says network created. Whenever you start Docker Compose, the first time it creates a network, and all these containers, which in this case are 3, the Mongo container, the SQL container, and our backend container, are all already connected via a network, which means this guy can access this guy can access this guy. And how can they access it? If you go back to a few slides, how are we accessing the MongoDB database container from our backend container? Through its name, the -- name argument that we gave when we were starting the container. Similarly here, you can reference from one container another container by using their names, and the names are these things right here. So the name of the 3 containers are MongoDB, MySQL, and custom app. If I want my custom app to talk to MongoDB, what will my final MongoDB URL be? It will be something like MongoDB : you see this? Do it here. MongoDB : the name of the other container, which in this case is MongoDB : 27017 / whatever. Cool. So what did we learn? Docker Compose automatically connects all containers that it starts via a network. You don't have to explicitly start a network and connect everything together. How do you add a volume? It's pretty straightforward. You add a volume key at the very end. Okay, bro, these are the volumes that I need. Oopsie daisy, missed it again. These are the volumes that I need, and wherever you want to use that volume, you just use it. For example, here I said, along with these ports, use these volumes. So if I had to start this locally, what would my command have been? It would have been docker run -p 27017:27017. This thing is referenced over here, and the other next thing I would have given it like -v MongoDB -data : data /db. This part is this thing right here. That's how you describe what Docker command should run, how you should finally run the containers in case of a Docker Compose file. I've made the same changes here. I added the volumes. I also referenced the volume here. Now if I run this, yeah, I figured I'd make some typo here. Line 6, 3, 4, 5, 6. There you go. Volume must be a mapping. It is a mapping. My bad. Now, there you go. Now, if I look at the logs, it says volume also created, container 1 created, container 2 created, and this guy can access this guy as long as my index.js file references MongoDB here, which in this case it does. This MongoDB is what is the name of the MongoDB container in the Docker Compose file, which is MongoDB. If I change this to, I don't know, MongoDB _DB, that is this change I need to make where in the index.js file as well, right here, because this specific string maps to the IP of the MongoDB container, which are connected already via a network. Which network? The network that was created when we started this container, which most probably is going to be this network right here. This network is automatically created when you start Docker Compose, and all your containers are connected via this specific network. And how do you reference one container from another? By their names. What are the names? MongoDB IDB for the first one, custom app for the second one. Cool. That's a decent checkpoint. It's the last thing to cover. Docker Compose. Take a breather here. Feel free to pause. But the next most interesting part is the thing that comes from here, which is we've understood a lot of things through these two videos. Can we now open an open source project and understand its Docker file? Can we create a Docker file for one of our own projects? This is what I call checkpointing to open source code bases, basically making sure that whatever you've learned is actually applicable in the real world, and it actually helps you somewhere rather than you copying what I did here and then feeling that Docker very well. You really know Docker well if you can now look at open source projects and understand a Docker file there, maybe contribute to it, make some changes there. That's when now I know Docker very well. So let's go to github.com/processing/p5js web editor. This is an open source project that comes to GSOC pretty often. And if I scroll down a little, you will see they have a docker-compose.yaml, a Docker compose development.yaml, and they also have a Docker file somewhere here. There we go. Let's begin with the Docker file and see if we are able to read through it, understand it. This is sort of a website, so it has a front end and a back end. Every website has its own set of technologies. So there might be things in the Docker file that you don't understand that are project specific, but I'll still try to explain this well. The Docker part of it you should understand well. Cool. This is a multi-stage build, as you can see, from Node.js as base. This part creates a first simple base image, creates app home as an environment variable. This is another way you can pass environment variables to a container if you want. You can use -e, or you can write env space the name of the environment variable and then pass it here. They put the working directory inside an environment variable, so it can be reused throughout the Docker file. Cool. Run make dir this specific thing, so it creates the working directory in case it does not exist, sets the working directory to that, exposes 8000 and 8002, most probably because this is exposes the front end, this exposes the back end, or vice versa. Cool. This is something both a local developer would need and a production database or production deployment would need, which is why they created this base image that both development and prod can sort of build out of. Let's look at the development image after that. What does it do? It says from base as development, set the node underscore env, this environment variable, to development. Why? This is used by a few libraries. A few libraries look at this environment variables and understand whether they should run in development mode or production mode. The main application logic might also use this somewhere to do things differently based on the environment. So they've like passed an environment variable here. Copies over package.jsons runs npm install. Hopefully you understand why this happened. This is for optimizing the build, making sure the layers are created one after the other, and the application logic is at the very end. First package.json and package-log.json are copied over, then you run npm install. Then this thing basically runs, like recompiles CSS most probably, like how CSS used to be done a while back, and something you need to do when you're running this locally. Copies over a bunch of other files, copies over webpack, copies over client, copies over server, basically copies over all the right set of files that it needs, copies over translations, and then another folder, and then finally runs npm start. So this, all of this is just, it could be copy ... but you don't want to copy over everything, so they explicitly copy over the files that they need, and then run npm start. This is how you start the project locally, this specific project if you want to. Again, you won't use Docker file, you will use Docker compose to start it. But if you wanted to just independently start the front end and the back end without the database, without the auxiliary services, you can use this Docker file and you can run Docker build with this specific target, development target locally, and it will just work. Similarly, if you want to use, there's another image here that they create from development as build, which means take everything from top to bottom. Development uses base, so base, then development, and then create build out of it. Add another environment variable here called production. So basically things from here are just for production, and run npm run build, which would something you do in production. Let's say this was a TypeScript project. I'm unsure if it is. Most probably it isn't. Might actually be client components. It isn't. But npm run build is like, we can just actually look at what npm run build does. If you have followed the script section, you can actually go to package.json and see what build does. So what does build do? It does npm run build client, npm run build server, npm run build examples. What does npm run build client do? You can just go here and see build client. It uses Webpack to compile your code. Basically, you can think of it as combining all the individual files into a single JavaScript file, something like that. It does a bunch of other things, but what does npm run build do? You can think of it as compressing all the JavaScript files into a single file that you can run in production. Because in production, you don't really care to see like very optimized, unoptimal code. You want the code to be very nice compressed. So that's what npm run build might do here. Most probably that is what it does. Like it does a bunch of other things, but the biggest thing, like one of the things that it does is it builds the project. Again, you'll actually have to go through the Webpack files and understand what exactly it does. but this is something you only need to do in production, which is why in the development we never saw npm run build. It's like fairly common if you're running a React project locally. If you're running it locally using development, you run npm run start. If you're deploying it, you'll first run build that will actually convert your TypeScript files into compressed JavaScript files, and then that is what you serve. Similarly here, when you're running it locally, all you need is npm run start. When you're running it in production, you first need to set the environment variable, run npm run build, then it says from base as production. Okay, so this is not production, this is actually build. Feel free to ignore this. Production one, the final one, says from base as production. This is the thing that you'll actually deploy on the internet when you're running this on an AWS machine, and you want, even if you're running it locally sometimes, to just see how things appear in production, you might use this. But more importantly, where will you actually use this? When you're deploying this project on an AWS machine in production. For that, this is the target that you will use. What does it say? Use the base image. On the base image, change the environment variable, copy your package.jsons, run npm install, build the CSS, copy from build app home dist./dist, which basically means copy over the dist folder into the dist folder of the final thing, and then run npm run start prod. Not this final thing, you understand, I guess, the container or the image, and then finally run npm run start prod. What does npm run start prod do? If I go to package.json, it does node index.js, which would be, to start this file here, which I guess will, find the dist/server.bundle.js started. That is how the Docker file is structured. Still might feel like you're missing a few things. I feel like I'm missing a few things because I have not looked at the application logic too much here. But hopefully you understand, this guy has 3 different targets that you can create. Development when you're running locally. Build, I don't know when. I guess so build, you basically, when you want to create the final distributions. By distributions, I mean final production files, JavaScript files, compressed files, but not actually run them, is when you could use this. As you can see, it does not have any CMD. That's another reason why you would use build. Why would we use build? Most probably you would use build in the CI/CD pipeline to make sure the tests are passing. So when someone checks in a code, like when someone sort of tries to contribute to this project, you'd probably want to run this stage to make sure the project actually builds. You don't really need to run the project, but you need to make sure the project builds, which is probably where you need this second stage. And then what's the final stage? The production stage, which actually is the target that you run when you're deploying this on the internet on AWS. Cool. This is the Docker file. Has 3 targets. What are we more interested in? The Docker compose file, because if you go to the contribution guidelines here, you will see it says you should just like run Docker compose up and it just starts. So for that, we need to understand what Docker compose looks like. So let's look at Docker compose development.yaml, which means if you're running it locally, this is probably the Docker compose file that you need to use, and you can simply use it by just doing something like Docker compose-f, give the path to the file, which in this case is docker-compose-development.yaml. So you can simply do something like this, and this will start the Docker container. Or if you just do Docker compose up, it will then pick the other compose file, which is the production compose file, which is something you don't want when you're running it locally. Let's look at the development build. What does it say? Start MongoDB, start the app, create a volume. Where does the volume reside? It is used here for MongoDB. What does the app say? It says build from this specific folder. This is the path to the Docker file. Target is development, which means where should you start it? You start it in development. Environment variable. Mongo URL is what? MongoDB:// the name of the Mongo service. This thing right here, / the DB, and the volumes. It also mounts dot to /user/source/app, most probably for the hot reloading thing. Also does another mount here, which report mappings. And there's another thing here called depends on, which basically means only start the app container after the Mongo container has started, because the app container sort of needs this. So if you use depends on, Docker compose will make sure first Mongo comes up. Only if Mongo comes up, we'll start the second container. Cool. Hopefully you understand this. If you want to set this up locally, I have a video where I discuss this in a lot of detail. Let's see. it is this video right here. So check out to one you. Feel free to go through this video. Here I also cover Docker Compose a little bit more. We basically go through this Docker Compose file again. But that's the high level of what is Docker, why you need Docker, what is Docker Compose, and how, if you understand everything, you can understand this in open source code basis. What are contributions that you can make if an open source project's Docker Compose file is not optimized, which means there is the problem of layers, extra layers being created and caching not happening correctly. You can fix that. As I said, someone fixed this in Backpack, where I created the Docker file which was not optimized. Someone came in and optimized it. Number two, you can find open source projects that don't have a Docker file yet and containerize them, which means if they use 10 different services, make sure you put them in the Docker Compose file. Also, you put their main code base in there, create like a very sort of clean file similar to this one, which will be pretty hard because you'll have to understand the internals of that specific project and what all you need to run to start the React project locally and then the backend locally and the Next.js app locally, for example. So it's like a pretty hard thing to do, but the good thing is once you do this, you understand the whole project very well. You get the context of what all services are needed to start this project. So if you find an open source project that does not have a Docker file, feel free to add it or optimize it. The other two things that you can do if you want to make a contribution, or you can just at least understand open source projects that have Docker files now. You don't really need to understand Docker file. If you think of it, you just need to know the commands, but now you know enough Docker to do a bunch of things like deploy your own apps or contribute and actually put Docker files somewhere. Cool, thank you. That was the end of the second video of the series, which says the 100x Devs YouTube Bootcamp. And now you can let me know what is the next video you want. Options are low latency trading systems, AI, Web3, some advanced React, advanced Mun stack. There's one more thing I'm forgetting, but yeah, just let me know whatever you want. Kubernetes maybe, yeah. Cool. Yeah, let me know what you want, and I'll see you guys in the next one. Bye-bye.